Sawadee Krap. Hello, everyone. Welcome you all to Energy Trends. This is a special program by TechnoBiz, a virtual event of the TechnoBiz. Just give you an idea about TechnoBiz virtual events. We host various online events focusing on the technologies and practices with reference industries. And today, the episode of the TechnoBiz virtual event on the energy trends. Focusing on the nano coatings for solar panels for better output. And our invited speaker is Dr. Sethi, is a managing director of the Nano Technologies. Before I let him give a presentation, let me quickly introduce to you about TechnoBiz. If you're interested in the TechnoBiz activities and particularly in the virtual events, you can download the flyer in your handout section. What kind of virtual events we have. TechnoBiz is based in Thailand and established in 2005. We are basically a international resource center for the polymer industries and also process and utility technologies. Energy is one of the areas that we focus. That's why we have this energy trends today. Our services are basically global, and we offer two types of services: professional education and business services. When it comes to the industry and the technology focus, we are into the rubber, plastics, and polyurethanes, adhesive coatings, energy and environment, and membranes and filtration, recycling and recovery, nanotechnology, smart manufacturing, and also chemical process. And we'll be covering also in the future on the cyber security and artificial intelligence because that's need of the hour, and so we are going into that area as well. And when it comes to our services, as I mentioned to you, we offer professional education. We have master classes, workshops, online training as well. And we offer the executive diploma 360 degrees, but we are doing only on the polymer industry. We have also skill assessment tests, publications, and we do have a digital library as well. When it comes to the business services, we organize, host exhibitions, trade exhibitions, conferences. We have virtual events like this today, webinars, road shows, and networking events. We also offer technical and business consulting, and we do the process audit. And most important, we are very active on marketing and branding of technologies and services. So this is a broader, areas of the services we have. If anybody interested, you can always reach out to me. So let's get to today's episode of the energy trends. The focus is on the nano coatings for solar panels for better power output. Our guest is Dr. Sethi. I'll just give you some background. He is well experienced in energy sector for last 35 years, particularly on engineering services, and he was PhD in material engineering as well. So it's a pleasure to have Dr. Sethi introducing about this. This is a new technology, and it's very good to know about how to improve the power output from the solar panel. So let's welcome Dr. Sethi to give a presentation on the nano coatings for solar panels for better power output.
Yeah. Hello, everybody. Sawadee Krap. So my name is Sethi. Thanks to the Energy Trends and Piram to organize this webinar. Happy to associate with them. I'm a materials engineer by profession, and I have done a PhD. I have been in the energy industry for more than 30 years. Also, entrepreneur, having started a company called Neon Infotech in 1999-2000 in Thailand. So it's one of the premier engineering services company working with oil and gas, petrochemicals, energy industry. And then we have offices in India, Korea, Myanmar, UAE, and US. So today I'm going to talk about nanotechnology and how we have developed a specialized coating for solar panels. So everybody in the world today is talking about carbon emissions and COP26, and then now COP28 is coming. and every government in the world, including the Thai government, the Indian government, and other governments have committed a certain timeline in which they will cut down on the carbon emissions. And because of that, whatever uh, health effect is there, they want to cut down that also. There have been effects on climate also. So all that is a concerted effort by public and the governments to ensure we use energy resources which are away from fossil fuels. The most common green and clean energy source, which is available in abundance by God, is solar energy. And when we talk of solar energy, there are certain challenges to that. The challenges are that solar panel, they've got a limited efficiency. Under standard test conditions or under ideal conditions, the efficiency is limited to about 20 to 22%. And under that standard conditions means that sun has to be at 90 degrees, the temperature has to be 25 degrees, the wind speed has to be 1.2 meters, and the humidity has to be below 60%. Now, these ideal conditions, they don't happen in the regular life because every 4 minutes, sun changes angle by 1 degree. So therefore, you have a window of only 4 minutes. Under normal conditions, the efficiency of solar panels is about 16 to 18%, which then further gets affected by dirt, by oil, by grime, by watermarks, by shadows, by bird droppings. And therefore, we need to clean it regularly. And that's regular cleaning, regular maintenance is a recurring cost. So this is where we have tried to come in. Uh, the for the inherent issue of the lower efficiency of the solar panel, and second, the need to clean and maintain the panels. So Tri-Nano Technologies have developed a solid state nano coating, which is about 0.4 micron thickness, made of inorganic ceramic oxide material and applied by electrodeposition. Each term I will explain later, but this coating, we attain three main properties: light trapping, self-cleaning, and anti-reflection. So how do we do the coating? So you can see on my screen on the left side, there is a control panel. This control panel actually controls the viscosity, the flow rate, the thickness, the current, the voltage, temperature, all these parameters, process parameters, and the coating thickness parameters. And there is a frame which sits on the panel, and this center part moves along X and Y direction on the solar panel. When it moves by virtue of the electric current, you'll get a microstructure something like this, which is a very dense bamboo tree forest-like structure. So when the light falls on it, it doesn't get reflected, it gets trapped. Now, when we are talking of thickness of 0.4 micron, which is thinner than human hair, this is not visible to the human eye. And besides, the coating is colorless. Now, the third one is the anti-souling. So we have a microstructure like this, whereby we increase the surface tension. So when anything falls on it, let's say watermarks or oil or dirt, etc., it doesn't get stuck. It doesn't get flattened out. It forms a globule. So there is a single point of contact with the glass surface, and therefore you can use high pressure air or just a very soft brush to brush it off. We have done testing at various places. One of them is NCPRE, National Center for Photovoltaic Research and Education. It is under Ministry of New and Renewable Energy in India. Before that, we did testing at AIT and NCDBA in Thailand. So this, what I'm showing you on my screen, is the results from NCPRE. So here you can see on the red side, this is the energy output from the coated panel. Black is uncoated and the blue is solar irradiance. This is of a typical day. I'll give you the data for longer period, but on a typical day, this is how they recorded it. So this is the power generation. You can see that coated has got a higher power generation than the uncoated one. On the right side, you see black is uncoated, red is uncoated. Now this here we are talking of temperature. green is the ambient temperature, and blue is the temperature difference between uncoated and coated. So here's the summary. You can see from 18 March to this is 8 May. I got the data till June 20th. So green is coated, orange is uncoated, and there is the energy difference. So you can see that there is clear difference in the energy generation of coated versus uncoated. When the NCPRE have summarized that temperature of the coated module is lower than the non-coated. So the cell temperature, because of the coating, goes down by about 2 degrees. And then they said that from day one, the coated panels had a higher energy output, energy generation by 4%. And that is because of the anti-reflective property of the coating. But as the panels are exposed to atmospheric conditions, the soiling increases, and therefore the energy output delta between coated and uncoated goes to 5 to 8%. So first is anti-reflective coating, by which you are getting 4%, and then as the soiling happens or dirt on the panel increases or the exposure to atmospheric conditions happens, then the energy efficiency goes further up to 8%. And these similar results were also recorded at NICE, National Institute of Solar Energy in Delhi. Toyota rooftop solar project, we did it in Malad. Residential rooftop, we did in Turbhe, and Tata Power in Bangalore. So different places in India, we did it, and the results were more or less the same. So when we talk of a typical 10 megawatt plant, let's say it's in desert area where the solar radiance is highest, but there the PPA rate, power purchase agreement, is the lowest of 2.36 rupees per unit, which is roughly about 3 cents US dollar per unit. Then if that plant, 10 megawatt plant, is coated with our coating, then the plant owner would get additional 720 megawatt hours unit per year extra power generation, which means around 17 lakh rupees, about $28,000 per year extra revenue. So besides this increase in the power by 4%, and also the reduction in the cleaning and maintenance cost, the coating has got a life of minimum 5 years, minimum. So therefore, the ROI for the coating can be obtained in about 18 months time. So what is the uniqueness about our coating? Like, there are many people who claim that they have the coating. So what is the difference between our coating and their coating? First, we have already applied for patent, and we are expecting it within this quarter. It has already been published, the uniqueness has been established, etc. Secondly, our coating can be applied to new panels as well as existing panel. New panel means if there is a PV panel manufacturer, then this process can be one of the steps in their manufacturing process, and thus the panels can be pre-coated, one part. Or if the panels are already in service, like a brownfield, we can also do the retrofitting, which means that we can take our equipment to the solar plant site and do the coating there. When we talk of currently the panel manufacturers, so they use plasma coating for doing anti-reflective coating, which is detrimental to the environment. Our coating, on the other hand, does not have any issues with respect to toxic waste or hazardous waste or any hazardous residue. It is environmentally friendly, and it is thermally and chemically stable. We are using only 220 volt normal power supply to do the coating. There is no treatment required before the coating or after the coating, which means that once the panel have been coated, they can be used immediately. The coating can be applied to all types of panel, polycrystalline, monocrystalline, thin film. Even the new technology which is coming up, perovskite, they can be done on that as well. And it's a solid phase deposition. So whatever coatings today are available in the market, commercial coatings available in the market today, whether it is Japan, Germany, India, US, or other parts of the world. For example, Solar Shark in UK, ARCI in India, Cemix in Singapore, and there's company Mitsui in Japan. So they are all providing liquid coatings. Secondly, most of the coatings are organic. And when they apply the coating, they are applying by method of spray or paint or brush method or even a plastic lamination kind of film. So in about 1.5 year time, these coatings generally they decompose, they get washed off, or they get withered away. There is a data on this in IIT Gandhinagar on the coatings only. They have researched for about 80-85 types of coating, and they have found that most of these coating they last just less than a year time. Secondly, besides the recurring cost of the coating for these commercial coatings, they normally charge anywhere between $14,000 to $17,000. So it becomes a recurring cost. Ours is much cheaper, gives much more benefits, and a long-lasting product. We are in B2B market segment, so our idea is that we will have certain select places, our research and testing facility, and we will do the coating along. We will work along with OEM, PV panel manufacturers, companies like maybe Zinco, maybe Tata Power, Wari, Alpex, etc. We'll work with them. But for the existing solar plant, we'll work with our resellers, distributors, or maybe EPC O&M contractors. So they will tell us what are the problems faced by the solar plant maker, and we will provide them the technology, we'll provide them the material, we'll provide them the training, and then they will use their crew to do the coating. The reason being that different places may have different issues, and it may be in remote areas also. Like for example, in Thailand also certain times we have the issue of crop burning, and then the carbon soot coming from Indonesia, Malaysia in the fields in down south, and they stick to the panel. This is very sticky and it's alkaline in nature. While near the coastal area, Phuket, maybe not Bangkok, but Phuket or around that area, it is salt water deposition, which is acidic in nature. While in north, it could be just plain dust. So different areas may have different issues. Similarly, in other parts of the world, like in Rajasthan or Gujarat in India, it's plain dust, but other places may have different issues. So the EPC contractor, O&M contractor, or the distributor will tell us what is the issue, and then we will provide them the solution, the training, and all the technology. So when we talk of the market is growing. The adaptability of solar for the energy needs is increasing by around 20% year on year. When we talk of, let's say, just India, so in India, it's the new manufacturing capacity is about 45 gigawatt. Installed capacity is around 67 gigawatt. So it's $1 billion industry already in India. In Thailand, it's about 40 gigawatt total, 35 gigawatt. So we are talking about $300-400 million. But in Southeast Asia, if we take together, it could be almost close to $700-800 million. In US, again, the manufacturing capacity is about 15 gigawatt. But when we talk of installed capacity, they have about 80 gigawatt. So again, US market is also close to $1 billion. So we can talk of Middle East, we can talk of Europe. So in all, the market is very big, and therefore we would like to work with partners, strategic partners, whom we will provide the technology, and they will have the power of infrastructure, investments, and team to do the coating. We are incubated by SIGN IIT Bombay. They have shareholding in our company, just a small one, but they are shareholding. We are also supported by MNRE, Ministry of New and Renewable Energy in India. So we work with NICE and NCPRE, and they charge us very little for that by support of MNRE. We are also registered under the Startup India program and MSME. We have won a couple of awards. We were the finalist selected to represent from India in Climate Tech Technology Conference in June this year. We have done a couple of pilots with PTT, GPSC, Tata Power, Wari Energies, Toyota Motors, and we have been in discussion with a couple of other companies to do pilots or small projects. Besides the use for solar panel, um, wherever there is an issue of transmissivity or reflectivity along with cleanliness, the coating can address that also. So let's say um, nowadays the glass buildings or glass windows, big glass windows are very common, but after some time they become dirty and you have to clean it. The other issue is that during summertime, in temperate climate like in Asia, Thailand, India, Middle East, uh, sunlight comes in and then your air conditioning cost would be higher. So we can make the coating in such a way that all the light is reflected so that your air conditioning cost is reduced while keeping the glass clean. While in Europe and America, we can have the transmission of light so that the heating cost is reduced, but still keeping the glass clean from snow, blizzard, etc. The coating can also be used for car windshield or any automobile windshield, can also be used for eyeglasses. It has got many other uses even in green hydrogen as well. So these are some of the things which we think can be developed once we have established for the solar market. This is our team. Dr. Mrs. Anshu Dandia is the fellow of the Royal Society of Chemistry, London, and she was former head of chemistry in University of Rajasthan. She is very well-known figure, uh, rewarded and awarded at international as well as national level, have published a lot of papers, very well-known figure in nanochemistry, green chemistry. Dr. Tanujal Bora is currently based in Thailand. He is the director for Center of Excellence in Nanotechnology at AIT, where we started our initial testing. My name is Sethi. As I said, I am a materials engineer and then PhD. I founded Neon Infotech. Shrisha Sethi is director, currently business and operations director. He did his engineering from Purdue and then now doing Sasin School of Management, Chula. Worked with Bechtel. Now he's full-time director. So all together, we have about almost 75 years of experience, the whole team in energy industry, and about 30 years of experience in nanotechnology and green energy, green chemistry. This is on a one lean canvas where we have summarized everything. So what is the efficiency of panels, existing alternatives, solutions, key matrices, unique value proposition, etc. So this is all about TriNano. I can also share some results uh, which I can show you. So this was uh, by NCPRE and at IIT Bombay. This is under Ministry of New and Renewable Energy. So they tested it from July last year and did various testings before and after coating. So before coating, the panels were tested. Then after coating, panels were tested. They were also checked for any scratches, cracks, etc. And then they did the summary like this from 18 March to April. So this is the summary. Then here the panels were tested again. I mean, this is rooftop where they were put on, and 18 March, April, May, June. So during rainy season also, there is, even during the peak rainy season, you can see that there is a difference in energy for coated versus uncoated. When the souling happened during April, May, the efficiency difference was almost 9 to 8%. We have ROI calculation also, in which in around 18 months you can get that. Then Tata Power, they did some testing. Um, then this is nice in Delhi. So they were doing for uh, Adani Solar, and then this is the energy output where the uncoated was 2.78 and 2.80, 2.84. So we have got various results. Um, I have got also the live here we put at a residential rooftop. So here also you can see the difference, even though it's peak rainy season there, but every day you can see that there is a difference of about 3%, 4% like that. So this is all about TriNano. Let me know if you have any questions. Uh, thank you.
Thank you very much, Dr. Harsh. Excellent presentation. I'm happy to know it's a very innovative technology, and at the same time, 4% say power output increase, and you're also very how to say, you comparing with other suppliers or other coatings, very positive news. Can you just ask the audience, guys, if you have any questions, you can post your questions now, so we will address it now in this Q&A session. Feel free to post your questions, so I will ask the question to Dr. Harsh. Yeah. Harsh, you've been in the industry 35 plus years in the energy sector.
Yes, yeah. I don't look that old, but yes, 30 years.
Yeah.
I am still, my hair, everything is in fine shape.
Okay. I want to understand, about solar energy. You are basically based in I think you're sometime in Thailand, sometime in India. Is that right? Yeah. So
yes.
if you compare with opportunities in Thailand and how the things are there in terms of solar energy for you, what kind of projections you're expecting here, and what kind of probably you have tested with the PTT. Yeah. You have tested the PTT
Yes.
as well, right? Yeah. So can you talk about experience with that one? Yeah.
So we tested with PTT. PTT now is more inclined towards green hydrogen because Thailand has got now the government focus is when you talk of incentives or subsidies, government is doing more on the rooftop solar. Ground mounted solar, there is very little subsidy now because we have a space restriction here as well. That is one of the reasons. Like countries like Japan, Korea, Taiwan, they have space restrictions. So the tendency would be more towards rooftop solar, and that is what it's growing. But and then the other technology which has come up is floating solar. Now, floating solar, even though it gives you advantage of space, but then the cleaning can become a very big issue, and that's where we can help. The cleaning cycle could be reduced, the panel temperature could be reduced, which means that the life of the panel could be longer. The PID we call because of the high temperature, which is process induced deterioration, that can reduce to a great extent. Yeah.
And you mentioned that the coating, the thickness is a 0.4 micron, less than our hair. And how hard it is to do that coating?
So we have our special technology here, which is again a patent where we use electrical current and then we ensure that the coating thickness is minimum. So when you're doing commercial coating, they use by spray method. So what happens is the coating thickness is 0.2, 0.3 mm, and thereby you tend to, compromise on the light trapping ability of solar panel. When you compromise that, there is an advantage that the cleaning is good, but then the light trapping is reduced. So we wanted both the properties to be there in the coating, and therefore we have to ensure that the coating thickness is maintained at a micron, 0.4 micron level. At the same time, there is less reflectivity and more light trapping so that you can generate more energy.
And what about other conventional, other suppliers of coatings? What thickness they do? Usually, the similar or?
No. So they are much thicker. So when we are talking of the other supplier, they use spray method or paint method. So in paint method, you cannot have a thickness of micron level. Normally, it will be like 0.2, 0.3 mm, which is much higher thickness.
So that's where you have a better advantage compared to the other suppliers, yeah. So,
yes.
And you mentioned about the different environments. Sometime in the beach you have all in acidic and salty weather. If you talk about deserts, you have a different weather. When you do this coating existing facilities, existing panels, do you need to take care of any surface treatment before you do the coating of this on nano coatings?
Yes, so the only requirement we have is that the panel should be clean, and there should not be any organic coating because organic coating tends to peel off. So if the panel is clean, then we can do it. What happens is that we have done testing on various environments, so very acidic to very basic, like pH value 5.8 to 8.1. we have also done testing up to 200 degrees centigrade. Now, in normal cases in brownfield, your temperature may go up to 60 degrees. But why we did that is when the panels are manufactured. So when they are doing the panel manufacturing, when they do the assembly, that time they use temperature up to 150 degrees centigrade. So therefore, we also tested our, if we are to do it in the manufacturing process of PV panels, then we have ensured that, yeah, our coating can sustain that up to temperature of 200 degrees centigrade.
I see, I see. And you talk about the life of coating is 4 years, is it right? Compared to the others, they have 2 years. So how this is, how it achieved 4 years? What is special feature about this nano coating? So that I think that the strength of that 4 years is much longer than the 2 years, the traditional way of coating, right? Yeah.
So actually, our coating can last more than 5 years. Actually, it is 5 years. It can be last more than 5 years. But the thing is that we started our commercial trials on commercial size panel like 440 watt and 540 watt in 2019 around October time. And then we got the results up to 9 months or 10 months of testing. So currently the coating has been on commercial panels in outdoor conditions has been in use for about 3.5 years. And that is why we can say minimum of 5 years. But in lab basis on microscopic plates, we have done testing and it may last up to 10 years also. But that data, we cannot compare it with the outdoor field data. So we are saying only 5 years. All other coatings which are there in commercial market, since they are liquid coatings, so what happens is that when there is rain or there are some atmospheric conditions, because of the sun, because it's all these things, they tend to decompose and therefore they last just about a year or so. We are talking of inorganic ceramic oxide, so that's one difference. Second is it's solid coating, and third we are applying by electric deposition method, so that makes the coating life longer.
Okay. There is one guy is asking questions about the if they like to do the field testing, you're open to offer this service. Yeah.
Yes, we are open to service. We have done field testing at couple of places already, so we are open to that. Yeah.
Yeah. So in Rajasthan, there is they have the facility of testing, so they like to cooperate with you. Okay.
Sure.
There is guys asking that you learned that you have installed one of the residential buildings in Navi Mumbai.
Navi Mumbai, yeah.
Yeah, they like to have the details about it and they like to visit it. So,
absolutely,
yeah.
Absolutely. They can visit. They can visit IIT Bombay. They can visit the residential rooftop. They can also see at Toyota. So Toyota also, I can share the data, but we have an NDA with them, so they can visit them also. I mean, we can ask for permissions, but residential rooftop they can visit anytime. No problem. We can get the permissions.
Is there any minimum capacities required to do this commercially or viable project in terms of the solar power capacity?
Yeah, so I mean, ideally, like if you are having maybe 10 panels or 20 panels, then you can do it by hand. We are talking of where you are using some way of mechanization, either by some cleaning agencies coming up, you have hired a contractor to do the O&M part, or you're using some coating. In that way, then we will be cheaper with them and we'll be providing better output. But if suppose you already have a plant and then you're looking at energy out efficiency to be better, then this may work. But if you're comparing with normal hiring a person and doing the cleaning, then we cannot compare to that.
And what your expectations in as year by year there will be decrease in the efficiency of the panel, right? And do you expect after the coating how this is going to be? Yes.
So what we have seen over our testing times, there is generally about a 1% degradation of the coating. So the coating can still last, and because there is a temperature difference of 2 degrees, so that will offset the degradation of the coating. Because in polycrystalline, every temperature every 1 degree lower temperature means about 0.35% efficiency increase. In monocrystalline, it's 0.3%. So it can be offset by that. But yeah, I mean, we'll have to look at longer period of time, maybe after 10 years, what happens. So that it can be recoated. The panels can be recoated, and on the existing coating, if there is something degraded, then you can recoat the panel.
So you suggest that every 5, an average, maybe after 5 years, you need to redo the coating. Yeah, that is the best way to go forward, is it?
Not necessarily. I mean, after 5 years, normally people, what they do is they have microinverters or string inverters, so they can check the energy efficiency, and when they see that it has become equal to non-coated panels or the panel efficiency which they used to get earlier, then they can opt for recoating. But I don't think it will be immediately after 5 years. It may be like 7, 8 years. It depends on the place where they are placed also. Like in Rajasthan, it may be faster, while in other places like Bombay or Telangana or in Bangkok, it may be slower. It may last up to 7, 8 years. While in Rajasthan, because of severe dust storm and all that, it may be 5, 6 years.
Here is an interesting question is from the Aniruddha. It's asking we are envisaging the robotic cleaning such that there will be a cleaning cycle daily. How much we can improve if we apply the tri-nano coating technology?
So I mean, companies like Ecopia, and there are a couple of other companies who do the robotic cleaning, and they claim either dry cleaning or they may have some water-based cleaning. So wherever they are, I believe that 50% reduction in the cleaning cycle can be achieved, at least 50%.
And of course, everybody wants the cost. Of course, you already talk about the ROI already. What is the cost per megawatt?
So when we talk of cost here, I mean, if we are to do in our own workshop in Navi Mumbai, or if we are to do at the panel manufacturing site, then we are charging somewhere around $12,000, $12,500 per megawatt. But if it is on site, then it may depend on the logistics cost. Like if you have to go to Ladakh or northeast of India, then there are transportation and other charges. But generally, in and around Bombay, we should be able to accommodate.
Here I have a question from Shrikant. He's asking that our 5 megawatt solar project in Maharashtra and 8-year completed for commissioning and existing panel is a Jinko 260 watt, and our panel efficiency is 0.5%. So is that necessary to do the coating? Also, is that coating also available at a lower rate 260 watt panel as well?
Yeah, so see, if the panels are already lasted 8 years, that means the efficiency must have come down from the day when they were installed. Now, since it is 5 megawatt plant, they may have some PPA agreement with the DISCOM or utility company, and they may not be achieving that revenue what they have initially achieved. So this will help them to increase the efficiency and get a better revenue. Plus, the coating may also extend the life of the panels and help in reduction of the maintenance and clean cost. So I believe that they can look at it. They may try one string or something, and then once it is successful, they can go for full plant.
Yeah. And you have your office is in Mumbai, right? Is it?
Yeah, Navi Mumbai. Yeah,
so
Navi
somebody wants the details about contact details. I will send them the details of yours. Okay, sure. So reach out to you.
Thank you.
Yeah.
Thank you.
Yeah. Finally, I want to touch. This is going to be patented very soon in this quarter. That's what he said. That's congratulations. The research into the real world. That's an adventure and also a lot of satisfaction. I think. Can you talk about the research team and their hard work and how many years it took, or developing this nano coating? Never been easy one, research into the commercialization, and this also a startup. You are in 35 plus years in the energy sector, and you're also part of this startup. So talk about this research to commercialization and the startup journey, please.
Yeah, so it's not an easy journey because it's a research-based project and we are talking of nanotechnology. So therefore, the equipment required for testing is also, it's difficult, it's expensive. But we started about 4 years back when the oil prices were hitting the roof, and some people came and said that, hey, energy prices are going up higher, and there has to be some change in the energy mix. Instead of like oil and gas, we have to look for alternative sources of energy. So solar is in abundance, but the limitation was because of the efficiency, because of the space it took, and then the cleaning cycle. There were issues earlier that unskilled people used to clean it, and then the panels got damaged, and because of that there was electrocution as well. Yeah. Some people got electrocuted as well. So we looked at that, and I thought, yeah, why not do something about it? Like, I'm a materials engineer, so let's try something. And that's how we started. And then we saw that, yes, there could be a possibility of not just energy. The poor people, they right now, at a 10 megawatt plant, if we get 720 megawatt hours per year, which means we are talking about 5,000 homes getting free electricity, which could make a social change as well. Like, right now, electricity costs are increasing because of the oil prices and all. And here we can make that change by utilizing our resources in a proper, productive way and making it available to all. So that's inspired me, and it took a long time. Still, it's a journey which we have to, continue and make sure that it reaches the masses.
Super, super. I think that you also have supported by the government organizations in India, like NICE and others. So that is a relief as well. That there is a lot of interest from them. Yeah, right.
Yes. Yeah.
And you have done the research. Yeah, go on. Yeah.
So initially, when we started, we looked at testing labs, and some of the testing labs, they quoted 25 lakhs one time testing, 25 lakhs, 30 lakhs, and I thought, oh, the startup is doomed. I mean, with just few testing, we will not be able to cover and sustain. So then we approached MNRE and NICE and CPRE, and they said, no, don't worry, we'll subsidize. So from 28 lakhs, we got the quotation for 80,000 rupees, which was a big relief. Like, from here,
yeah,
we could do that. We could continue.
Yeah, so that's nice. I think that's a big relief, and it's also motivates you, just something to look forward reality of the project, right? Yeah. You also done the field test in Thailand at the AIT. That's what you mentioned. Yeah. So how was your experience at the AIT?
So AIT also has got AIT along with NSTDA. They are close by, so they have got good facilities for testing, and initial testing was done. But that time our equipment was slow, and COVID happened. That was the time when we were doing. COVID happened, so the restrictions were very big. Like, in AIT, we could not enter. NSTDA entry was banned. Even the customer side, where we used to go and do some monitoring or checking, it was not allowed. Almost like 1.5 years. And during that time, I happened to go to Dubai for a conference there, and I passed via Mumbai. And in Mumbai, I saw, what is COVID? Nobody was bothered about COVID at all. They said, no, there's no COVID here. So then I said, this is interesting, because in Thailand, we are still wearing masks. If you go to India, nobody wears a mask. If you wear a mask, they'll look at you like, do you have COVID? It's the other way around.
Yeah.
So then we looked at the supply chain, and we looked at the government policy support system and all. And we thought that, okay, it makes sense to start there.
Yeah, excellent technology, and really useful for the industry. I believe that you're closely working with the panel supplier manufacturers. Is it right? Yeah.
Yes. Yeah. That's right. Yes.
And so, what's the future plan? Go on.
Yeah. So we have been working with. We have done pilots with Tata Power. We have done with Wari. We are in discussions with a couple of others, including the American manufacturer First Solar. We have been in discussions with Avada as well, Vikram Solar, a couple of manufacturers. So the idea is that if they adopt the technology, then the panels will be pre-coated, because challenges of doing the coating afterwards when they are installed, they are much more. You have to go to the site. If it is raining, then you can't do the coating. You would like to do the coating during night time only. That could also be a challenge, because during daytime you're getting the output. So if this is happening in the production process, then all those issues could be sorted out.
I think pre-coating is a pragmatic and is much easier to manage compared to the already installed panels. And it's not just only the night and day. Sometimes it's difficult to go up, and you have to be more careful. Yeah, so roofs may not be strong sometimes. So
We have encountered this, like somewhere the panels when they're installed, they've used very light structure, so the ground subsidence is there, the panels are not even, there's misalignment, roofs are not strong, all these issues are there. So we have to help address that market as well. But if it is done from the panel stage, then slowly we can bridge that gap between coated panels coming from factory to those ones which are installed in the field.
So finally, what's future plans for the Tri-Nano technologies? How do you foresee the next 10 years? Or of course, this is as you know, we are everybody's talking about a low carbon society or zero carbon society, or ESG. So many taglines about sustainability and things. So what's plans for you with reference to the Tri-Nano?
So what we are planning is that at least usage of the resources should be optimum, and this can help in the usage of resources. Whatever your existing ones, you can use for a longer period of time for a better output. So one part is that. Then we will continue to work on that through our own research lab, working with partners, so that the technology can also be adapted for other uses. Green buildings, for example, even car air conditioning, you can reduce. The car gasoline usage could be reduced. Even during green hydrogen production, we are looking at ways how we can incorporate during the hydrolysis process. There would be heat exchangers, and the coating may be looked at. Maybe we'll have to do a lot of work on that, but then it can be done where the corrosion is inhibited while you are still making sure that the heat transmissivity is attained. So there are a few other uses we would like to look at in future, and ensure that we are all are working towards leaving a generation which has far more greener earth than what we are today.
Absolutely. Dr. Harsh, thank you very much. Actually, officially, we need to ask you, give the final remarks to welcome the people or thanking the audience. So any final remarks to the audience, please?
Let's all work together. We have our own bit. I mean, I've seen in the past, we have used fossil fuels to the extent that there has been global changes in the climate. There have been effects on the human health. So let's try to at least salvage some part, work whatever way you can in making sure that we adapt and we use better, make better use of our resources. My step is Tri-Nano. Maybe you could look at other parts, other technologies, but let's work together for a greener, better earth. Thank you.
Okay, thank you very much, Dr. Harsh. Excellent presentation about the nano coatings for solar panels for the better power output. And actually, many of the audience convey their congratulations and thank you for a nice presentation. And I'm going to share you some of these comments from the audience to you as well. Okay, and I wish you the best, and do the wonders for the green world for the future generation. Yeah, we already reached certain age, so we had to look for a better future for the next generation. So this solar technology really makes a difference, and thank you very much for being the part of today's energy trends. I appreciate the time. Thank you very much.
Thank you. And if anybody wants to get in touch, please feel free. I would be happy to share and talk about it. Thank you. Thank you, Pram, and thank you, Energy Trends.
Thank you very much, Sarika. Thank you. Okay, guys, that's the end of the presentation of the session on energy trends with the focus on the nano coatings for solar panels for the better power output by Dr. Sethi. He's the managing director of the Nano Technologies. I really believe, and I also feel that you learn a lot about, the benefits of this nanotechnology. Please be in touch with Harsh to work together, as he's asking, work together for the better world. Yeah, thank you all. Bye bye for now.